to go over WarmUp 9.3. And the first problem, where is our variable located? Where is the variable located on in the first problem? In the parentheses, which is in the log. Thank you. So the variable is within the log. But I see that this second log doesn't have any variables. So that's just a regular number that I can actually figure out what that number is. I can use the change of base formula. How is this number really figured out? Log 4 divided by log 6. So let me go take my calculator and figure out what that value is. So I'm going to do log 4, close the parentheses, divided by log 6. Okay, so this amount here is actually 0.7, where'd it go? What was it? 0.737. Okay, 7737. So I've got log base 6 of x plus 3 plus 0.7737 equals 2. Okay, so how should I continue solving this?
Subtract.
Good. Subtract this 0.7737 over. And so I have log base 6 of x plus 3 equals whatever that is. So I'm going to figure out that's 2 minus the answer from up above. And that gives me 1.2263. Okay, so now I just have a single log. Whenever you just have a single log, how do you get rid of one single log? Nope, you don't divide, because you cannot separate log and x plus 3.
Put log on the other side?
Nope. When you have a single log, you have to write it in exponential form. So what does that mean? You have to write it in exponential form. Yes, you rearrange it as an exponent, which means 6 to the 1.2263 power equals x plus 3. So 6 to the 1.2263 power equals x plus 3. Okay, so what is that? 6 to the 1.2263 power. Oh, it's 9. That's nice. Okay, so 9 equals x plus 3. And then now what? Subtract 3. So therefore, x is 6. Okay. Now, where was the log located? Where? Within the log. Do you remember that if our variable is within a log, we have extraneous solutions because our domain is limited. This is the one time, the only time we have to check is when our variable is within the log, because if it's out here somewhere, our answer was out here somewhere, then it's extraneous. So I'm going to take 6 and I'm going to write it here. And that gave me 9 inside that log. So is that acceptable? Yes, it is. Because it's 9, it's over here, and so that answer was over here somewhere. Correct. If I had, say, like a -6 here, then a -6 plus 3 would have given me a negative within the log, and I cannot have a negative within the log. That's imaginary or non-real. So, therefore, our answer is 6, and that is acceptable. Okay, let's do number 2. Number 2, where is the variable located? It's different than number 1. The variable is located up in the exponent. So I'm going to take this guy down out of the exponent by logging both sides. So I'm going to log both sides, and then that allows me to bring this x down. So x log 7 equals log 13. And so now how can I solve for x this time? Divide by log 7. So I'm going to divide by log 7. And so x equals whatever that log 13 divided by log 7 was, which is 1.3181. Do I have to check this one? It's an exponential function. Tell me about the domain of my exponential function. It's all real numbers, so anything's acceptable for an exponential function. My variable's up there the next time. Okay, next. Number 3, what am I going to do? What? Okay, quadratic. How do I do quadratic? Good. What's that called when I need to get those two logs together? Vocabulary? Condense. Very good. I'm going to condense those two logs. So I've got log 4 of x minus 3 times x plus 3 equals 2. Now look, I have a single log. What do we do on number 1 to get rid of a single log? Not multiply, not divide. Write it in exponential form. You have to get that. If you have a single log, you write it in exponential form. So that's this. 4 squared equals this result. So 4 squared equals, and I'm going to go ahead and FOIL this out and do it a step at a time. X squared minus 9. Okay? And you can solve that from there. So I've got 16 equals x squared minus 9. And add that 9 over. X squared equals 25. How are you going to solve that for the x? Take the square root. And it is plus or minus 5.
But it would be plus 5 if you're on the string.
Correct. Well, let's look. Let's take a negative 5. That's the one we think might be bad. So put a negative 5 up here within the log and check it. Negative 5 minus 3 makes that having a negative 8 there, and that's all bad. So negative 5 doesn't work. So therefore, only positive 5 works. Well, let's check it. Positive 5 minus 3 is good. Positive 5 plus 3 is positive, so that's all good. So 5 checks out. And we had to check it because the variable was located where?
In the log.
In the log. If it's in the log, you have to check it. Okay, next. Our variable is located up in the exponent, so how am I going to get it down? Take the log both sides. Now, because e is involved, what kind of log am I going to take? I'm going to take a natural log. Pull this x plus 1 down. Now, what do you know about natural log of e? Yep, it's just the number 1. So this is really saying x plus 1 equals natural log of 17, which is 2.8332. I'm going to subtract 1, so x is 1.8332. Do I need to check this one? No. Where is my variable? In the exponent. Exponential functions have unlimited domain. As long as it's real, it's okay. Only if it's located within the log do I have to check it. I mean, you're welcome to, but it's not necessary. Okay. Next, let me just go ahead and put the answers on this, and you get the idea. I've gone through those pretty much in depth. The answer here was x equals 1. The answer for number 6, x equals 2.1203. I did not have to check either one of those.